So what I've got open here is the FuturesCollectorIntStream implementation, which is something you'll be using for assignment number 3. And this is just a slight variation on the futures collector that we looked at in the previous lesson, but it customizes it for int streams as opposed to objects of type T. So you'll notice it's not a generic class. It kind of customizes it for int stream. As you can see here, what it does is it is going to basically implement the collector interface. We have the first parameter be the type of the stream, which in this case is a completable future to integer. And we then have the mutable result container, which is a list of completable futures to integers. And then finally, we have the return result that comes back from the finisher, which is completable future to int stream. And the reason we do this is it allows your implementation to be a little bit more concise, and you can use some methods in a more succinct way than having to deal with these conversions and so on. So just to walk through how the code looks for this is going to look very familiar. You can see here that we've got the supplier, which returns an array list constructor that makes a new array list, which will hold this list of completable futures to integers. We have the accumulator, which, as you can see, this is a rather long-winded method name, so let's go ahead and make it a little easier to read. So we've got accumulator, which is going to return a method reference to the add method on list. So that's what's going to be used to add each element in the stream into the mutable result container. Then down here we have the combiner, which, as we saw before, is just used to take two sublists and basically combine them together, so we only have one list. And then down here we've got the finisher, which again is a bit long, so let's make it a little easier to read. So you can see here that this is very much like the one we looked at before in the previous lesson, the main difference being again that we're going to take a list of completable futures to integers and return a completable future to an int stream, as opposed to a completable future to a list of type T or something else. Also notice here, unlike the previous example where I had returning a list of items of type T, this time I'm having the collector return a stream. So we're actually getting the result back as a stream. Before, in the previous example, we were getting the result back as a list. And again, when you look at assignment number 3, you'll see that by doing it this way, by getting back the results as an int stream, it simplifies the subsequent code that we need to do with then apply, because we don't have to convert anything into a stream. We can just go ahead and use the results of the stream directly. That's very, very powerful. Here's what the finisher method looks like. Most of it looks very similar to before. We get our futures, which is the mutable result container. We call all of on completable future, passing in the futures list after first converting it to an array of completable futures. That will give back the one and only completable future that we then are going to use with a completion stage method, then apply, waiting for all those computations to finish running that were coming out of this array. And then when they're done, we're going to go ahead and convert the futures list into a stream. And then we're going to use map to int. And we're going to use map to int because we're going to be returning an int stream here. So we need to use map to int. So we want a primitive type, not a reference type like integer. And we're going to use the join method to basically join everything together, converting from completable future to integer into basically a stream of ints with our int stream. And you'll also notice that there's no use of collect here. So there is no collector being run in the context of the finisher. Instead, we're returning a completable future, because that's what then apply is going to return, to an int stream, which is what map to int is going to return. So once again, that's going to greatly simplify the code in your assignment 3 that comes after this, where you're going to need to be able to take the results, and when the completable future to the int stream is done, you will then take that int stream and do something with it. And again, you'll have to figure out what you do with it, but it's pretty straightforward. So the ability to use these completable future collector-like mechanisms, in this particular case, the FuturesCollectorIntStream, that will simplify several parts of your implementation in assignment 3. And you'll see it's going to make it much cleaner and neater once you understand the concept of collectors in the context of basically things that that will use the completable futures framework and the all of operator to aggregate and concentrate all the asynchronous processing behind a single completable future that only triggers when all the asynchronous processing is done. And then again, you can see we just have the characteristics method that says we don't care what the ordering is, and we have the toFutureFactor method that makes a FuturesCollectorIntStream. So I just wanted to kind of do a little deeper dive showing how this particular class works, because you'll have to understand how this class works in order to be able to use it in your implementation. You don't have to know how to implement it, although it's cool to learn how to implement it, but you don't have to implement it. You just have to know how to use it. And you'll be using it in the Completable Futures crawler class in a couple of different places. And the comments that are in that class give you a good indication of when you should use it. Yes? I'm sorry, I couldn't understand. Oh, yeah, good question. So the question was, are these future collectors, they're not provided by the Java Standard Library. Those are things that I wrote. So as you can see, there's different ways to do it, right? You can have it work with items of type T. You can have it return a completable future to a list of type T. In this case, we have it return a completable future to a stream or an int stream in this case. So there's a couple different ways you can implement this. And that's probably why it doesn't come out of the box. But it's a really, really useful thing to know about. And you'll see it simplifies your code substantially. And also makes it ridiculously efficient. And I think if we were to do the timing, if we had a good way of doing accurate timing of the different implementations of parallel streams, completable futures, and so on, we would probably find that the completable futures version works the fastest. And it's in no small part to the use of these very cool mechanisms. Okay, let's see. So we're actually pretty much done with completable futures stuff. There's something that we'll probably start to talk about on Wednesday, which will be a more detailed example showing how to use some of this stuff. So hopefully that'll be helpful to you. It might also give you some hints on how to do your programming assignment, although you should definitely start before then. It's not going to be a one-to-one mapping, but it'll at least give you some hints that might be helpful. And that's what I think we'll do then. So just a couple things. Make sure you go out and pull the new code. I posted the video walkthrough yesterday evening. So if you go to YouTube and you look under the class, you look way down here, see we have walkthrough of assignment 3 for CS 253. That's us. And the video is a little bit longer than usual because the skeletons are more complicated. I did have one little mistake in the video, but I fixed the code to make it more clear what was going on. So if you look at the skeleton, you'll see it explains what you need to do. And basically it has to do with the method where we asynchronously start downloading an HTML page, get back a completable future. Then in parallel, we go ahead and look at the number of images on the page and download them and transform them. And then we also have another, and that's one completable future running asynchronously. Then we have another completable future that's also running asynchronously that will then traverse recursively all the links accessible from that page and download and transform and store all those images. And we'll then have two completable futures to these asynchronous computations that are running in the background. And the fourth step is we're going to make a call to another method, which is going to combine those two things together. So after the completable future finishes for all the images that have been downloaded, transformed, and stored, and after the completable future that will be recursively traversing all the links reachable from that page has finished. When both those things are done, we will take the results and combine them and then sum them up. So if you read the code in the skeletons, it tells you what to do. With the video, I had cut and pasted the wrong thing in there, but it should be clear if you read the code. And I think I describe what's supposed to happen there as well. Okay. Well, that's probably what we need to cover for today. We have plenty of stuff